Hello and welcome to this video in the series on carboxyl derivatives. My name is Ochem, and in this video we'll be ranking the reactivity of different carboxylic acid derivatives. Derivatives of carboxylic acids all have the same structure, an acyl group with another functional group attached to the carbonyl carbon. The reactivity of carboxyl derivatives depends on the electronegativity of the leaving group. If the functional group in green is stable on its own, after it has broken the bond to the carbonyl carbon, then it's a good leaving group, and that carboxyl derivative will be more reactive. However, if the leaving group is unstable on its own, then the carboxyl derivative is less reactive. Like I mentioned earlier, what characterizes a good leaving group is dependent on its electronegativity. For example, acyl halides have a halogen attached to the carbonyl carbon. Halogens are extremely electronegative and will draw electron density toward itself. Because of this property, it will be happy to grab the electrons in the covalent bond and exist in solution with a formal negative charge. The only exception to this is fluorine. Fluorine is so small that the bond between the carbon and the fluorine is extremely short, and its electronegativity discourages the polarizability required for bond breaking. All other halogens are happy to leave and take those electrons with them. The same electronegativity reason will also explain the next step in the reaction, which will be covered in another video. Carboxylic acid derivatives are often subject to nucleophilic attack, and binding the carbonyl carbon to an electron withdrawing group like a halogen will make the carbonyl carbon an excellent electrophile. Acyl halides are the most reactive out of all carboxylic acid derivatives. The next most reactive are carboxylic acid anhydrides. All acid anhydrides have the same structure. An acyl group bound to another oxygen and then bound to another acyl group. Kind of like if I jammed two acids together. Anhydrides are also quite reactive because there is electronegativity coming from two sources, both of these oxygens. That makes for a stable leaving group and a reactive carbonyl carbon. Next on the reactivity list are esters and carboxylic acids. Esters and carboxylic acids are approximately equally reactive. And looking at the structure, it's apparent why. There is only one electronegative atom in both the OR and the OH groups. The least reactive of the set are amides. While nitrogens are slightly more electronegative than the carbon, the lone pair on the nitrogen outweighs any inductive effect, and the net effect is that amines are electron donating. This makes for a less electrophilic carbonyl carbon, and the amine is not happy to leave with those electrons. Let's use this information to solve the applied question. The applied question asks to order the carboxylic acid derivatives in order of reactivity, starting with the most reactive. Recall the order of reactivity. Acyl halides are the most reactive, then anhydrides, then esters and acids, then amides. Taking a look at the molecules, the very far right is acetyl chloride, which would fall under the umbrella of acyl chlorides. No other acyl halides are in the question stem, so this would be the most reactive. The next reactive would be any anhydrides, which are usually easy to spot with the neighboring carbonyl carbons. This molecule is acetic anhydride, one of the simplest anhydrides, so this is number 2. The third most reactive would be any esters or acids, and methyl ethanoate is an ester, so this is number 3. Finally, the remaining molecule is ethanamide. Remember that amides are the least reactive of all carboxylic acid derivatives, so this would be last. To recap, remember to use the electronegativity trends to help you distinguish the reactivity of all of the carboxylic acid derivatives. Organic chemistry questions often will ask you to rank the reactivities of molecules, so this is a great skill to have under your belt.